think we are live. Just camera. There we go. Welcome on in, everyone. I am Robert, the AP Math Guy, and tonight we are going to continue where we left off on calculus when we talk about linear approximation. So, let's go ahead and do a mad tap to get tonight's live started. While you're doing that, I want to go ahead and first I'm going to try and wave at everyone who I can click the button and wave to. But if I can't click a button to wave at you, I'll wave at you now. Hi, everyone. So, I want to show you something. We are almost done Calculus 1. Remember when I said that we would be starting Calculus 2, I thought, in early October? Turns out that we are going to be I took a look at the schedule today, and it turns out that we're going to be starting Calculus 2, I think, sometime in the next 2 weeks. So, here is a schedule of every live that I am doing this week at this time. So we're getting closer and closer to the end of Calc 1, the end of differential calculus, and moving into integral calculus. So yeah, thank you all for mad tapping on the likes. Also, last time I checked, I am 297 followers away from 2,000. So again, thank you all for joining me on this endeavor to bring calculus to the world of TikTok and the world at large. So yeah, how's everyone's Monday night doing? Anyone watch the Lions-Ravens game tonight? I just caught the end of it. Yeah. Detroit won. And it's funny because next week the Chiefs and the Ravens play each other, and one of them is going to start 1-3. So it's going to be really interesting to see who does. And I mean, at the beginning of the season, I didn't think they were going to be in that position, but I guess any given Sunday, right? Awesome. So we are at 1K likes. So thank you, everyone. So tonight, as I said before, we're going to be doing linear approximation. So, what does that look like? Just quickly wave at a couple more people. And again, I will do one more wave for you all. Hi, everyone. So, what does linear approximation look like? So, suppose that I want to find the value of a function at a point. Let's say I want to find the value of f of x, or I want to find the value of f of x equals x squared plus 7, and I want to find it when x is equal to 3.01. So, what we can do is we can use something called linear approximation to give us an approximate answer of what this problem would be. Now, for every problem tonight, what I'm going to do is, as soon as we are done the linear approximation, I'm going to actually plug in the value for x and see what we get. I just found my fraction calculator today, so that's always awesome. So, let's go ahead and get started with this first one. So, how do I use linear approximation to help me find the value of this function at this point? Well, I can do that by using using the the equation of a tangent line. So I can figure out relatively easily what the value of this is when x equals 3. So I'm going to go ahead and attempt to draw this graph. 1, 2, 3, 4, 5, 6, 7. Going to do something like that. And then when x equals 3, 2, 3, and then here's my little offset. So here, I know it's not to scale, but I'm going to make it work. Is this Calc 1 or Calc 2? This is Calc 1. This is just the end of Calc 1. Just plug in for x? We could. We could definitely plug in for x. But, yeah, right. But sometimes we're going to run into a function where if I plug in directly, it's going to get complicated. Thank you, Madville, for the follow. So, what I'm going to do is I'm essentially going to use the slope of the tangent line to help me find the value of this function at this point. So, remember the the formula to find this equation of a tangent line. It's y minus y1 is equal to m times x minus x1. So, now let's plug in a couple things. Well, what is m? M is the slope, but we also know another name for a slope. It's called the derivative. So the derivative, remember, tells the story of the slope. So I'm going to plug in, instead of m, I'm going to have m be f prime of x. So I have, so far I have y minus y1 is equal to f prime of x times x minus x1. Or what I'm gonna let x1 also be called a. So from here, I'm gonna add y1 to both sides, and I'm going to give it a new name. So let a equal x1 and f of then f of a equals y1, right? Because remember, f of a is just a fancy way of saying y. So I can plug in everything, and I'm left with y equals f of a plus f prime of a times x minus a. And this is our linear approximation formula. So let me write that down. Linear approximation formula. Thank you, Osmain, for sharing the live. Linear approximation formula. Now, let's use this to find this. So I'm gonna let a equal 3. So I know that a. So I'm gonna let a equal 3. Because why 3? Well, it's gonna be 3 because 3 is relatively close to 3. So then I get y is equal to f of 3 plus f prime of 3 times x minus 3. Or actually, I now have to let x be 3.01. So 3.01. So if I plug in 3 for x up here, and it's kind of hard to see, and I apologize, let me try and focus in a little more and zoom in. There we go. All right, so when I plug in 3 for x here, what would f of x be? So f of 3 is equal to what? Frog says 16. Ryan says 16. Nene says f3. Okay. So yeah, remember, anytime I have a number inside of parentheses with this f, it means take this number and plug it in everywhere you see x. So this is going to be 3 squared plus 7. 3 squared is 9 plus 7 equals 16. Thank you, Frog. Thank you, Ryan. So we know what f of 3 is. Now, thank you, Kevin, for sharing the live. Now, let's find the derivative of this. So remember, I'm going to need to use the power rule for this one. And what does the power rule say? Well, the power rule says that if I have a variable raised to a power. Hey, Brandsy, how's it going? If I have variable raised to power, its derivative is I'm going to take this exponent, move it out front, multiply by whatever coefficient's in front, and subtract 1 from the exponent. So f prime of x is equal to take my variable, move it out front, so that's going to be 2, x to the 2 minus 1, which is 1. And remember that a variable without an exponent is the same as that variable raised to the first power. And then when I take the derivative of 7, so 7 is a constant. How do I know it's a constant? It's a constant because there's no variable next to it. So the derivative of a constant is always 0. So this is, in essence, 2x plus 0. Now, because I have plus 0, I'm not going to... 2x plus 0 is the same as 2x, so I'm not going to write 2x. So now, let's go ahead and find the derivative at 3. So I have f prime of 3 is equal to 2 times 3. What does 2 times 3 equal? Thank you, Nene. That's exactly right. So the answer is 6. So f prime of 3 is equal to 6. What happened to the minus 1 you mentioned? Did I mention a minus 1? It's possible that I did, but I just don't recall. Where did I say minus 1? When I was... Oh, here? So, I just gave them new names. If you're talking about X1 and Y1, I just gave them new names. Thank you, user, for the follow. Yeah, no problem. Always happy to help, Des. Thank you, Luis, for the follow. Okay, so now I have everything I need to solve this problem. So I'm going to start by finding f of 3, which is 16. So this is going to be y is equal to 16 plus f prime of 3. What is f prime of 3? F prime of 3 is 6. So this is going to be 6 times 3.01 minus 3. Why is this math 1431? What is math 1431? I'm not sure. So from here, 3.01 minus 3 is going to give me 0.01. 6 times 0.01 is going to give me 0.06. So this is going to be 16 plus 0.06, which means my answer is going to be 16.06. Now, what I'm going to do is I want to see how close my answer, my approximation is to the actual value. Okay, Nene, what questions do you have? Here? Is that where I lost you? Okay, so here, do we agree that this is the form, that we have this as our formula? Okay, maybe not. Okay, so this is called linear approximation. So to find the value of y, I'm going to take, so my goal is to approximate the value of this function at this point, at 3.01. Now, I can't quickly figure out what the value of f of x of this is when x is 3.01. However, I can quickly figure out a nearby point, which is 3. So, didn't I plug in the... Nope, I have not plugged in yet. I'm going to plug in just a moment. So, what I'm doing from here is because... So, I'm going to let my x be my point of interest, and I'm going to let a be a point near... a relatively nice point nearby. Do we agree that 3 is close to 3.01? Yeah. Yeah, no problem. So, where did I get 16? So here, okay, so we do agree on that. So, I'm using this point to approximate the value at this point. So, this formula allows me to do it. A is my yes, that's exactly right, Frog. So so x is my point of interest, and a is a nearby point. So here, I let a equal 3. So according to the formula, I need to take f of x at x equals 3 plus f prime of x at x equals 3, and then subtract my point of interest from my nice point. So that's how I got this. From here, and I saw multiple people ask this, so I'll show it to you. So here's where I got the 16. So f of a, well, a is 3, so I took 3, plugged it into this equation. 3 squared is 9 plus 7 gives me 16. So this went over here. And then I needed to find the derivative of f at 3. So I took the derivative. That's what this is. Plugged in 3, and that gave me 6. So that is where the 6 came from. From here, I just did order of operations to simplify, which gave me 16.06. Now, let's see what happens. Let's see how close we were. So let's see what the actual value at 3.01 is. So our function was f of x is equal to 3.01, not negative, point. There we go. And actually, I don't even need parentheses. That is going to be squared plus 7. Let's see what the actual value is. 16.0601. So, would we agree that this is a good approximation of the value? Or would we not? Nene says, yeah. Do we 50-50, Jay? Okay. Well, I mean, I can't think of much of a much better approximation. What functions does this allow for faster calculations? So, really, it's a way for us to approximate a value using a tangent line. Oh, thank you, Victoria, for the heart me. I don't know if I don't know if you just sent that or if it's been up there a while. If it has, I apologize for missing it, but thank you. Thank you, Drew, for the follow. All right. So there are a few different functions where it's going to allow us to. So is the linear approach a way to double check that the work is correct? Kind of. It's a way for us to know to approximate what a value is. Zoom out. Okay. Although let's cool it on the all caps, please. Thank you, Lisa in Seattle, for the follow. All right. So, let's go ahead and try another one. Let's say that f of x is equal to x cubed minus 2x plus 3. And I want to find f of 1.99. Now, I don't know about you, but if you were to plug in 1.99 for x, that's going to get kind of messy. So, what I'm going to do is I'm going to use my linear approximation formula. Is there a quote unquote nice number that is close to 1.99? Yeah, Nene, exactly. Yes, Alexander. So I'm going to let A equal 2. Then f of 1.99 is going to approximately equal, and I'm going to say equal for this, but just know that this is an approximation. This is not going to be perfect. So I agree. This is going to be a squiggly equal sign. You're right. I agree with you. So here it's going to be f of 2 plus f prime of 2 times 1.99 minus 2. You're right. You're exactly right. Yep. Indeed it is, Hayden. Why does the derivative matter in an approximation function? Because we're using the tangent line to approximate, and the derivative gives us the slope of the tangent line at a point. Good question. Calc 1? Yep. Towards the end of Calc 1, but yes. I'm learning derivatives this week. You got any advice? how are you on your? How did you do on your limit on a scale of 1 to 10? You got a 100% on your limit, Seth? Awesome. So just know any of the derivative rules that you're going to see can be derived using limits. So if you some rules are easier to remember than others, um, but just know that any derivative rule can be derived using the limits. Oh, thank you, Hayden, for the follow. Oh, by the way, someone asked me if I could do a related rates problem. I don't remember who it was. But anyway, thank you, Terrence, for sharing the live. You're doing linear approximation in Calc 3 now. That's awesome, Ethan. So I guess perfect timing. I never took calculus. I'm just exploring math now as an adult. You're a great teacher, by the way. Thank you, Lisa. I really appreciate that. So, here, what I'm going to do is first, I'm going to thank you, Lisa, for the 5 roses. So is this Calc 3? You could see it in Calc 3, but it also appears in Calc 1 towards the end. Calc 3 is multi-dimensional. This is single variable. Oh wow, 11k likes. Last night I was struggling to get 2k likes, so thank you everyone. Thank you Andy for the follow. So here, first step, I'm going to take 2 and I'm going to plug it in everywhere I see an X. Thank you EF01582 for the follow, and thank you Nene for the follow. So, f of 2 is going to equal what? It's going to equal 2 cubed minus 2x, 2 times 2 plus 3. So that's 2 cubed is going to give me 8. 8 minus 2 times 2. 2 times 2 is 4. And that's going to be minus 4 plus 3. If that's the case where f of 2 is equal to 8 minus 4 plus 3, what would f of 2 be? Thank you, Fady, and thank you, Whodat, for the follows. Right, thank you, Frog. It's going to be 7. 8 minus 4 is 4 plus 3 is 7. Yes, Drew, that's right. So this, we're going to replace it with 7. Now, I need to find the derivative of this function at x equals 2. Thank you, It's a Chris, for the follow. So, what is the derivative of this function going to be, do you think? Thank you, Gris1221, for the follow. That's right, Frog. Why? Because of power rule. And for those of you just joining us, let me see if I can quickly find my derivative rules. Oh, here they are. So, here is power rule. So what does power rule say? Power rule says if I have a variable raised to the nth power, its derivative means that I can take this n, move it out front, multiply it by whatever my coefficient is, and subtract 1 from the exponent. So here, I have x cubed. So remember that if I don't have a coefficient, it means the coefficient is 1. So I take my 3, move it out front, multiply it by 1. That gives me 3. And then x to the 3 minus 1 is 2. So that's going to be 3x squared. And then remember, a variable without an exponent is the same as a variable to the first power. So I'm going to take my 1, move it out front. 1 times negative 2 gives me negative 2. And then I have x to the 1 minus 1, which is 0. And remember that x to the 0 is equal to 1, so long as x doesn't equal 0 itself. So here, instead of writing negative 2 times 1, I can just write it as negative 2. Now the derivative of plus 3, well, 3 doesn't have a variable next to it, so it's a constant. And if f of x is equal to a constant, then f prime of x is going to be 0. So this is essentially 3x squared minus 2 times 1 plus 0. So rather than include the times 1 and plus 0, I'm just going to leave it like this. Now, I'm going to plug in my 2 into my derivative. So I have f prime of 2 is going to equal 3 times 2 squared minus 2. If that's the case, then what does f prime of 2 equal? Alexander says 10. Do we have agreement? Let me take a quick sip of water here while Frog says 10. I love my GF says I agree. Fantastic. So, that is right. 2 times 2 squared is 4. 4 times 3 is 12. 12 minus 2 is 10. So that is what's going to go over here. So now, let's go ahead and now I have everything I need to solve for this. So, yes, I should be using this notation. So L of 1.99 is approximately equal to 7 plus 10 times 1.99 minus 2. Now, if that's the case, what would my answer be? That's a 1.99, by the way, in the parentheses. I'll give you a moment to work on that. What would the answer be? Joy says 24.99. Do we have agreement? Alex agrees. All right. So I have 1.99 minus 2 gives me negative 0.01, or 0.01 rather. So this would be 7 plus 10 times negative 0.01. 10 times negative 0.01. That's going to give me, well, when I'm multiplying by 10, I can move the decimal one place to the right. So this is going to be 7 minus 0.1. So the linear approximation of f of x at x equals 1.99 is approximately 6.9. Thank you, Greg, for the follow. Or agree. I do apologize if I pronounced your name incorrectly. So, let's see how close that approximation is. So, I'm now going to actually plug in 1.99 for x and see what I get. So I have 1.99 cubed minus 2 times 1.99 plus 3. And I get 6.900599. What do we think? Is that a good approximation? Was our approximation good or was it not good? No, this is calculus. Yeah, it was a pretty good approximation. We were only off by what? We were only off by about 599, what is it? Tenths, hundredths, thousandths, ten thousandths, hundred thousandths, millionths. So we were off by 599 millionths. I'd say that's pretty good. Being only off. What would I say is the best way or method to studying in general? So here's how I like to study. So when I study for a test, now keep in mind it's been about 10 years since um I've taken the test, but for me if I were to do it again, and I tell my students all the time, people think, and I don't know why they think this, but they think that the longer you study, the more you're going to remember. And that's true for a certain point. However, at some point, there's a thing called the law of diminishing returns. And what that basically means is, in this context, is that if I study for X amount of time, at some point, I'm not going to be able to retain any more information. So if you're going to do a long-term studying event, or if you're going to do long-term study, I would recommend breaking it up into chunks of like 30 minutes. So you study for 30 minutes, take a break for 10 minutes. Study for 30 minutes, take a break for 10 minutes. That way, the law of diminishing returns hits you less than if you were to just study for 4 hours straight. Because even me, I find that after about 2 hours of doing the same thing, I just start making careless mistakes and stuff like, and um it doesn't make sense for me to continue. How hard of a test in college Calc 1 in comparison to what mitts? Because if I were comparing them to like differential equations, I'd give them like a 2. But if you're talking about you're talking about like division, then I would give it a 10. But and that's the other thing, right? It depends on who your teacher is. Can we do something harder? Well, tonight we're going to be focusing solely on linear approximation. Oh, I remember the other thing I wanted to say. So someone asked me earlier if we did a if I could do related rates. So actually, I've already done 3 lives on related rates. So, if you want to catch those, I have them uploaded here on this channel. And as I said, I have three different related rates videos up there. I think I spent about 5 or 6 hours. Thank you, Chess Amateur, for the follow. So yeah, if you go here to this and then go to this channel, you'll be able to find all of my past lives since middle of August. I would show you the new one of those that I did tonight, but I'm gonna save that for the end. So yeah. Wait, why does the limit definition make no sense? What is it about the limit definition that doesn't make sense? Pomodoro technique. Let me just do a quick look, and thank you RMJ for sharing the live. Right. Yes, that's exactly right. That's exactly right, Kim. I do subscribe to the Pomodoro technique. Yes. I just find that for me, I retain more information if I'm able to take breaks in between. Thank you, Chess Amateur, for the heart me. Thank you so much for that. I agree. I fully agree, Kim. It's a great tool. I mean, that's how I work on stuff for my business as well, 30 minutes at a time. All right. So, shall we try another one? Let's see. Do I have enough room here to do another problem? I think I do. I wonder, should I turn the page now? I have all this space that I could use. Yeah, let's do it. So I'm going to go ahead and separate the work that we've done so far. There we go. So let's let f of x equal 1 plus 1 over x. And I want to find, or actually approximate the value of f of 1.1. So again, here's my formula for the linear approximation. So L of x is approximately equal to f of a plus f prime of a times x minus a. So my x value is my point of interest, which is 1.1. What should I choose for a that's relatively close to 1 and that will work nicer than 1.1? What do you think? So let x equal 1.1 and let a equal what? What should I let a be? I agree, Don. I agree, Joy. Let's let a be 1. So then L of 1.1 is approximately equal to f of 1 plus f prime of 1 times 1.1 minus 1. Okay, so let's find f of 1. So f of 1 is equal to 1 plus 1 over 1. What would f of 1 be? Joy says 2. Do we have agreement? Don says 2. Yeah, that's right. 1 divided by 1 is 1, and 1 plus 1 is 2. Thank you, Prime. Thank you, Don. Thank you, Joy. So f of 1 is 2. So here, I'll be able to plug in 2. Now, I need to take the derivative of that function. So here, I'm going to manipulate this a little bit. So, remember, so remember that 1 over x is the same as x to the negative first. So now f of x is equal to, not plus, is equal to 1 plus x to the negative first. I'm glad to see you feel that way, Don. Go ahead and let's go ahead and take the derivative of 1 plus x to the negative first. So what would the derivative of that be? Prime says negative 1x to the negative second. Can we go over conversions of what? Dwight says negative x to the negative second. A Taylor series is a better linear approximation, right? I believe so, yes. But we don't quite know how to do the Taylor series yet. So, Prime and Joint, can you convert that to have a positive exponent? What would that be? You're absolutely right about the derivative, but what would that be with a positive exponent? Alexis says negative positive 1. Not quite. So remember, use this rule. Okay, Abby, not quite. So remember, if I have x raised to the nth power, I take my exponent, move it out front, and subtract 1 to the exponent. Almost, Joy. What does it mean to have... How do I convert this from a negative exponent to a positive exponent? Right, Prime. That's exactly right. Although, watch your signs. Thank you, Man, for the follow. So here, first I'm going to start by taking the derivative of 1. So, derivative of 1 is a constant. And so, if this is a constant, then its derivative is 0. I don't know. Okay, Alexia, thank you for the honesty. That's perfectly fine. So, f prime of x is going to be derivative of 1 is 0. And then I have x to the negative first. So, x to the negative first. Take the negative 1, move it out front, and multiply it by 1. And then subtract 1 from the exponent. So this would be negative 1 times x to the negative second. But remember, in order for me to make this a positive exponent, I need to take anything that I'm raising to that power and move it into the denominator. So this would be negative 1 over x squared. So now, from here, what I'm going to do is I'm going to take 1 and I'm going to plug it everywhere I see an x here. So this is going to be f prime of 1 is going to equal negative 1 over 1 squared. If that's the case, then what does f prime of 1 equal? Prime says -1. Do we have agreement? Well, I agree. Josh says -1. Calculus is so fun, I don't know why. I agree. 1 squared is 1. -1 divided by 1 is -1. So my -1 is going to go here. -1. Okay, so now I have everything I need to solve for that. So, linear approximation at 1.1 is approximately equal to f of 1, which we discovered was 2. Take the negative, so this would be minus 1 times 1.1 minus 1. 1.1 minus 1 gives me 1.1. So this would be -1 times 0.1. And if that's true, then what must this be? Right prime. -1 times 0.1 is going to be -0.1. So 2 minus 0.1 is going to be 1.9. That's right. That's it. Now, let's plug in 1.1 and see what I get. So I have on clear 1 plus 1 over 1.1. And we get 1.90909090 dot dot dot. So yeah, would you say that our approximation was a good approximation? Or would you say it's not a good approximation? What do you think? Let's go indeed, Prime. Can we go over ASVAB arithmetic questions? I actually don't go over the ASVAB, but I do have someone that I would recommend that you do follow. She goes over the ASVAB. So that would be ACG math tutoring. Yeah, no problem. She does a really good job of explaining the ASVAB. Much better than I could. Oh, cool. That's actually good to know. Now 1.1 would have been better. I took that to go and get into the Air Force. I'm a veteran. Thank you for your service, Lisa. My brother almost went into the Air Force. We were trying to get him to go because he wanted to work as a he wanted to do he wanted to fix jet engines, but he decided not to. Was I a math major or engineering? I studied math. That is what I did. You were asking me about integration, Jose. So, we're not going to do integration tonight. Um, what we're going to do is I'm starting integration, I think, in about 2 weeks. Thank you, Great Branch. My cousin was jet mechanic in the Air Force. Okay, I'll pay attention now. Awesome. Well, thank your cousin for his service, for their service as well. But yeah, so anyway, we will do a couple more of these, and then we're going to go ahead and call it a night. I have 3 more prepared. Let's go ahead and do those next couple. So I no longer have enough room to do a new problem. So I'm going to go ahead and turn the page. Yes, that is exactly your plan. We're going to do 3 more and then we're going to call it. Because it is it's 20 to 1 in the morning here in the East Coast. So, f of x. Let's do some trig. Let's say f of x is equal to tan x. And I want to approximate value of, do I need to refocus the camera? Of f of 3.1. Thank you for the 12 roses, Lisa. So, what would be a, so here I'm gonna write the formula again for us so that we don't forget. So linear approximation is L of x is equal to f of a plus f prime of a times x minus a. Thank you, Sour Apples, for sharing the live. So now, my x value, so x is going to equal 3.1. What value of a do you think I should choose? Especially given that I'm dealing with a trig function. I actually don't want to use 3 here. 3 is not going to give me such a nice number when I plug it in for x. But there's a better number that we can use, one that's actually closer to 3.1, and it's a really famous number. Yes. Yes. I don't know if that's a sun or just a star, but yeah, that's right. That's right, Star. That's right, Eve. That's right, Andrew. We're going to use pi. So we're going to let a equal pi. And I'm not going to use an approximation. I'm just going to use pi. So here I have L of 3.1. This should be approximate. 3.1 is approximately equal. Cool, you're going to guess that? Awesome, Lisa. So I have f of pi plus f prime of pi times 3.1 minus pi. So, now we need to find f of pi and f prime of pi. Thank you, Andrew, for the follow. So here is where we're going to need another tool to help us find at least f of pi. So I'll be right back in a sec. I'm still in the room. I'm just gonna, oh, there it is. Here is the unit circle. So this is going to help us find our points of interest. So here we start at 0 radians. And the reason I'm using pi is because pi radians is going to give us a nice number. So here, in order to use the unit circle, I start here at the point 1, 0, and I go counterclockwise. So if I'm finding tan of a positive number, I go counterclockwise. And if I want to find tangent of a negative number, I go clockwise. So since pi is positive, am I going clockwise or counterclockwise? Dwight says, I think that means counterclockwise. Victoria says counterclockwise. Yeah. Thank you, Joy, and thank you, Victoria. We're going counterclockwise. How many radians? We're going pi radians. So what I'm going to do is I'm going to start going counterclockwise, and I'm going to stop when this number is pi. So I'm going to start here. I'm going to go counterclockwise, and I'm going to stop right here. So here is pi radians. So when we look at our points, the point is cosine of theta, comma sine of theta. But I don't want cosine or sine. I want tangent. Does anyone here know how to find tangent using sine and cosine? What do we think? And here's the puzzle piece. Gotta love it. Juan says sine over cosine. 505 says sine over cosine. E says sine over cosine. Victoria says sine over cosine. Right. So, tangent, tan theta, is equal to sine theta over cosine theta. Cosine over sine? No, that's actually cotangent, which is the reciprocal of tangent. Thank you, Juan, for the follow. So here, my sine is my y value. What's my y value at pi? It's 0. So tan of pi is equal to 0 over my cosine, which is negative 1. So I have 0 divided by negative 1. And the last time I checked, 0 divided by anything that's not 0 is equal to 0. So we know that this will be able to plug in 0. Now, let's find the derivative of tangent. So, does anyone know what the derivative of tangent is? If not, that's okay. E says secant squared. Do we have agreement? Joyce says secant squared. Yeah. So, let's take a look at our rule. So, if f of x is equal to tan, then the derivative of tan x is going to be secant squared of x. So, f prime of x is going to be secant squared of x. And now, I want to find f prime of pi. So that's going to be secant squared of pi. Now, this is really easy to mess up, so I'm going to do a conversion. So secant, so remember, secant of x is equal to 1 over cosine of x. So here, it's not going to be cosine, it's going to be cosine squared. So this is going to be 1 over cosine squared of pi. Now, what did we say cosine of pi was again? Here's pi, and remember that cosine is the x value. So what's the x value of this point right here? I wish I knew how to pronounce that, but you say -1, 505 says 1, E says 1, -1, Drew says -1. So it looks like we're all pretty much in consensus that cosine is -1. Thank you, Shamrocks, for the follow. I think those are Shamrocks. So, but remember, I want cosine squared. So cosine is -1. So cosine squared is equal to -1 times -1. So this is 1 over -1 all squared, which would give me 1 over 1. -1 times -1 is 1. 1 over 1 equals 1. So when I go here, I'll be able to plug in 1 over there. Thank you for the follow. Again, I wish I could pronounce that. I'm having trouble seeing what it is. Can you just directly find x and y, put it into mx plus b form and sub in approximate? So we're kind of doing that already, because this, just like y equals mx plus b form, is an equation of a line. In fact, this derives from what's called point slope form. But sometimes here, it's not going to be very clean. If I plug in 3.1 for x, tangent of 3.1, I can promise you, is not going to be very clean. So now, what I'm going to do is I'm going to find the linear approximation at 3.1. So L of 3.1 is equal to, does everyone mind if I just write nothing here instead of 0? Do I have everyone's permission, or should I write in 0 anyway? I'm okay either way. What should I do? As a visual, okay, I'll write in 0. So f of pi is 0, plus f prime of pi is 1, times 3.1 minus pi. And now, let's see what we got. Yeah, I'm going to use 3.14 now for pi. So I have 3.1 minus 3.14. So this is going to be 0 plus 1 times negative 3.1 minus 3.14 is negative 0.04. So then this is going to be 1 times anything is itself, plus 0 is itself. So this is going to be negative 0.004, or 0.04. And that is our approximation. Yes, I do need to put the squiggly equal signs. Thank you, Jacob, for the follow. So now, let's see what the actual value of that is. So I need to make sure before I start that my calculator is in the right mode. So I'm going to show you all how to do that on TI-83. So I'm going to go to Window. Nope. That's not what I want. I want I want Mode. And here, Radian is selected. So let's say if it were in degree, I'd go down to Radian and I'd hit the Enter sign. So now my calculator is in Radian mode. So now if I quit out of here, Now it'll know, okay, this whatever value plugs in, that's how many radians, not how many degrees. Because I'll show you the difference between radians and degrees here in a moment. So let's plug in tangent 3.1. Hopefully we get something around negative 0.04. You can also program your chem notes into the calc to cheat. I am not going to condone cheating on here. Yeah, so I get negative 0.0416166.546. Go on, dot, dot, dot. Would you say that our approximation was a good approximation? Or was it not a good approximation? Yeah, I would say it's a pretty good approximation. I would definitely say that. We're only off by this much, which is not a whole lot, relatively speaking. Now, I wanted to show you the difference between... So this is in radians mode. What would happen... What would it show if I were in degrees? So let me move my calculator down here. So let me go back to here. I'm going to go into degrees this time. That calculator has been through a lot, it seems. Yeah, this is a pretty old calculator. I've had this one since high school, and that was about 15, 20 years ago. So now, if I tried the same thing, I would get that. These two, while they're seemingly close, are actually relatively different. It's more pronounced if I choose pi. So let's say instead of tangent we do sine of pi. Where's pi? Pi is right here. In degrees, it would be that. Whereas when in radians, it would be 0. Two very different answers. So that's why it's important to know what your calculator is set to. All right. Any questions on that? Any questions at all? Any books you recommend at the end of your class that go into the basics of today? So I personally have a couple. Personally have a couple textbooks that I'm using right now while I'm getting my calculus notebook ready to go. As soon as that's done, I'm going to recommend my notebook. But right now, one of the books that I'm using is the Princeton Review's AP Calculus prep books. I have this one as BC, and I also have the AB version. Again, not sponsored. I'm not sponsored by Princeton Review at all. That's just what I'm using for. Though if the Princeton Review does hear about this and want to work out a sponsorship, feel free to contact me. Anyway, so yeah, no problem, Lisa. Always happy to help. I think I spent like, let me see, how much did I spend on these? I spent about $30 on each. If you want a full blown textbook, I'm still looking for the one that I like most. So, but if I find one, I'll let you know. Thank you, Lisa, for another 5 roses. Just noticed that, by the way. Okay. Can I do a limit as x approaches infinity problem? Yeah, so here, I'm going to focus on linear approximation tonight, but I did a live already on that. So if you go here, go to this channel, you should be able to find that live. So every live that I've done thus far is here, including this one as soon as I'm done. No problem, Victoria. No problem at all. All right, let's do 2 more and then we'll call it. I do have it, finally. I've had it for a while, but I haven't been very active on it, so but these are forcing me to get back active on there too, as well as here. I have to be active in more than one place. So f of x is equal to, that's okay as long as we get some vids since we prefer live. Fair enough. Fair enough. So let's do this. Let's do e to the x. I want to approximate value of f of 0.99. So remember, L of 0.99 is going to equal, well, I need to choose an A. That'll get me something halfway nice when I plug in for X. What should I let A be? That's relatively close to 0.99. Rada says 1, 505 says 1. I agree. So let's let A equal 1. A equal 1. So this is going to be f of 1 plus f prime of 1 times 0.99 minus 1. So now I need to find f of 1 and f prime of 1. Let's find f of 1 first. So f of 1 is equal to e to the first. Is this Newton's method? Is it Newton's method? I don't think so. I think Newton's method is a little different. It could be. Newton's method. Nope, that's something completely different. That has to deal with sequences. Newton's method is an iterative algorithm that finds increasingly accurate approximations to the roots of a differentiable real function. So yeah, so e to the first, well, anything raised to the first power is itself. I'm just going to let it be e. which we'll say is approximately, which we'll say is 2.72. Why E and not M? What is M? So E is Euler's number. I could do an entire one of these days I might actually do a couple lives on math history. How, if I did that, would that be something that would be interesting? Learning a little bit of math history. All right. Do no idea, bro. I just made that up. Like Isaac Newton invented calculus. Lol. Victoria says yes. Rada says yeah, man. Duly noted. I may have a live where if I don't know what I'm gonna do, I might just talk math history. So here now, I'm going to go ahead and take the derivative of e to the x. Well, e to the x is a really special derivative. Does anyone know what the derivative of e to the x is? I'll give you a hint. It's actually right in front of you. The derivative of e to the x, yeah, it's e to the x. That's right. So, e to the x is a special derivative in that it is one of the few, if not only, functions whose derivative is itself. So f prime of x is going to be e to the x. And so f prime of 1 is just e to the first. Well, we already found that, right? So it's going to be approximately 2.72. So here we go. So the linear approximation at 0.99 is approximately equal to 2.72 plus 2.72 times, what is 0.99 minus 1? Oh, I definitely have the debate between Isaac Newton and Leibniz planned as well. Rada says 0.01, Victoria says 0.01. That's right, Joy. Watch your signs, right? Because negative, if I had 1 minus 0.99, it would be positive. But that's right, it's negative. So this is going to be negative 0.01. And so when I multiply a number by 0.01, I'm going to move the decimal 2 places to the left. So this is going to be 0.99 is approximately equal to 2.72 minus, right, because negative times positive times negative is negative. That's going to be negative. Move the decimal place twice to the right, twice to the left, so that's going to be 0.0272. So therefore, this is going to approximately equal what? 2.72 minus 0.0272. So I have 2.72 minus 0.0272. That's 8296.2. So yeah, my answer is 2.6928. Let's see how close we were. So E to be 0.99, not negative 99. Now we're going to end up with a very different answer. If you are able to record these and post, therefore, that's. So yeah, so that's what I get. So would you say that's a good estimate? Would you say our approximation was good? Or would you say it's not a good estimate? Yeah, I would agree. I don't think we were that far off. Yeah. So it's funny that you mentioned that, Lisa, because I already do. All of my lives are already there. Yes. So now it is time for the final problem. Final problem. What's this technique called again? This is called linear approximation. So yeah, so let's. So there are 19 of us in here. To get to unlock the final problem, let's get up to 20,000 likes. Let's do a quick mad tap to 20k. Let us do a quick mad tap of that heart till we get to 20,000. Hopefully everyone's having a good time tonight. I know I am. It's always fun being here talking calculus with everyone. Thank you, Lisa, for the 8 more roses. I'm being so for real. The kid I babysit is in an advanced class and it scares me how smart he is. Yep. What's he taking? What math is he taking right now? He's doing pre-calc at 8. That's actually very impressive. I'm impressed. That's amazing. He might be. He might very well be. Actually, no, he's not going to be that. He's going to be himself. He'll be himself, and maybe him will be at Einstein's level. I don't know why I babysit him. He could take care of himself. I'm not sure about that. Um, just because he can do levels of math greater than everyone else. I know I took algebra when I was 8, and I still couldn't take care of it myself. Agreed. Absolutely. 100% agreed, Lisa. I took calculus twice as I took calculus twice. Oh, fair enough. Sorry about that. No, I get it now. Good one, Grass. It's hard it's hard to get to sense sarcasm from texting. I still making mac and cheese every week. Well, yep, that sounds about right. But yeah, so yeah. So as I said before, I'm planning on finishing up Calculus One by the end of September. Hi, Caden. How's it going? Welcome, welcome on in. We are just getting ready to do the final problem, which I actually have right in front of me. Are you going to make videos on pre-calculus? That's the plan. And actually, I'm going to be doing a second live here, not tonight, but I'm going to be announcing a second live. So I'm going to be focusing on more VAT level when I do that. So what I did think about this for a little bit. So I'm gonna have this live that's focused in on like calculus and above, and the other live's gonna focus on everything that leads up to calculus. Well, like algebra and geometry and pre-calc and stuff like that. I don't know if too many people who would be interested in me saying okay, what comes after 3. Bro, can you explain why to use linear approximation when you can just plug in e to the 90 to the 0.99 in your calculator? You could, but this is a way for us to be able to figure out its value by hand, approximate value. Now, you could you just plug in to your calculator VAT? Sure, but where's the fun in that? I've been struggling with polar coordinates lately, so I'd appreciate if you did a little lesson on it. Okay. I actually think I have polar coordinates already on my list. Let me bring out while we're doing the Mad Tap, let me go ahead and bring out my topic request list. Oh, by the way, I can now cross this off because we're doing that tonight. So, let's see, do I have polar coordinates here? Riemann sums, 3x3 systems, dot cross products. Let's see. I don't. Okay, adding it to the list. We're going to touch on polar coordinates. I think that's going to be... I haven't planned out Calc 2 yet, but if I had to guess, given the list that's in front of me with... So I have most every topic mapped out. I think I'm going to be doing polar coordinates sometime around... I would probably say, if I had to guess, Thanksgiving. Any solving of differential equations with Taylor series expansion, that's gonna be way later on. We're not anywhere near Taylor series quite yet. We're just finishing Calculus 1 here in the next couple weeks. That's great. My finals in mid-December. Perfect. Perfect, Caden. So we are almost at 20K. You all only have less than 2K to go. I know you got this. Go, chat. What part of Calc 1 am I on? So I am actually towards the end of Calculus 1. I only have maybe like 10 or 11 more topics to go. Is Washer Method Calc 1 or 2? 2. It is Calc 2. Most anything involving integration is Calc 2. Or single variable integration is Calc 2. Alright, we're less than 1,000 away from getting to the final problem. You all are doing great. I forgot implicit differentiation? Okay. It's actually funny because I just did a live on implicit differentiation, I think last week. So, if you go... I had this note card like 6 times. So, if you go... Oh, by the way, I'm also in... Here it is. If you go here... If you go here and here, you'll be able to find that live for implicit differentiation. I saw the word Euler in my 3D software where I learned how to rig characters. Okay. Yeah, no problem, Joe. Happy to help. Alright, I don't know. I can't see the decimal, so I can't see how close you are to 20K, but I have a funny feeling you're almost there. Is 10 weeks rushed to learn Calc 1? Well, considering an average semester, I think is 15. It's a little rushed, but it's... I've seen people try to do it in like 2 weeks, and I'm like, why are we spending that little time on calculus? I never got it. Oh, cool. We're at 20K likes. Or at least on my screen, we're at 20K likes. Oh, those are brutal. Those 6-week semesters are awful. What do you recommend for this learning calculus? This particular topic or calculus in general, Lisa? For those learning calculus. Okay, so the thing about oh, perfect, we hit 20K. So the thing about calculus, the one piece of advice that I give my students is that if you're going to take calculus, make sure that you understand your algebra and your trig well. Because they say the hardest part of calculus isn't calculus. The hardest part of calculus is the algebra. I was going to take Calc 2 in a 6-week summer semester, but ended up failing Calc 1 the spring before. Okay. Yeah, I would not recommend, unless you absolutely have to, I would not recommend taking it in like a 6 or 8 week course. To me, for me, that's just too fast. Okay. I definitely don't recommend you take it in 2 weeks. Because that is just a bad idea. Alright. Let's go ahead and look at the final problem. So I have f of x is equal to the natural log of 1 plus x. And I want to approximate the value of f of 0.1. So my x here is going to be 0.1. What should I let my a value be? Let me move it up to the center. I agree, Joy. Let's let a be 0. So let a equal 0. Then L of 0.1 is going to approximately equal f of 0 plus f prime of 0 times 0.1 minus 0. So first, we need to find f of 0 and f prime of 0. Now, if I plug in 0 for x, I get the natural log of 1 plus 0. What is 1 plus 0? Joyce says 1. Nope, not quite, Joe. 505 says 1. Yeah, 1 plus 0 is 1, right? So, f of 0 is equal to the natural log of 1 plus 0, which is equal to the natural log of 1. Now, does anyone know the natural log of 1? Right, Joe, it's going to be 0. That's right, Joy. Thank you. Both, it's 0. And how do we know this? Well, natural log and e are inverse functions. So the natural log of 1 is log base e. And what does that mean? Well, if I have natural log of 1 equals 0, that means that e to the 0 is equal to 1. Both of these are true state. If one of these is true, then the other is automatically true. Well, this one is always true, right? Because any number other than 0 to the 0 power is 1. And now, so we found f of 0, which is 0. So I'll write that here. So I'll draw a little arrow, put 0 there. Now I need to find f prime of 0. So derivative of natural log, and this is why I saved this one to the end. So I have in here function trapped inside another function. So what we're going to do is we're going to use this thing called the chain rule. And what does the chain rule say? Well, the chain rule says that if I have a function trapped in another function, I take the derivative of the outer function, leaving the inside alone, and then I take the derivative of the inside. So instead of taking the derivative of natural log of 1 plus x, let's take the derivative of the natural log of bottle cap. What is the derivative of the natural log of bottle cap? What is the derivative of 1 over bottle, or natural log of bottle cap? I almost just said the answer. Yeah, it's derivative of bottle cap over bottle cap. So it's 1 over the bottle thing underneath the bottle cap. What's underneath the bottle cap? It's 1 plus x. And then because I had to cover it with a bottle cap, now that I've revealed it, I have to take the derivative of what was underneath. What's the derivative of 1 plus x? Joe says 1. Aaron says 1. Joyce says 1. Yeah. Derivative of 1 is 0 because 1 is a constant. And the derivative of x to the first, is 1 times x to the 1 minus 1, which is 0. 1 times 1 is 1. No bottle cap this time. Well, actually, I just used the bottle cap. Turns out it wasn't that necessary, but yes, I just used the bottle cap. So now, I'm going to plug in 0 here. So now, f prime of 0 is equal to 1 over 1 plus 0. What would that give me? Please read the Bible. I do every day. DeVito says 1. Joyce says 1. Aaron says 1. Yeah. 1 plus 0. Kim says 1. Thank you all. So 1 plus 0 is 1. And 1 divided by 1 gives me 1. So this value, I'm going to plug in as 1. So now I have everything I need to solve this. So I have the linear approximation of 0.1 is approximately equal to f of 0, which is 0, plus f prime of 0, which is 1, times 0.1 minus 0. So, if that's the case, what would my answer be? Aaron says 0.1. Joyce says 0.1. Thank you, Mathematic Fanatic, for the follow. So yeah, my answer ends up being 0.1. Why? Because 0.1 minus 0 is 0.1. 1 times anything is itself, and 0 plus anything is itself. So this is going to be 0.1. And that's it. And now I'm going to go ahead and plug it into my calculator and see what the actual value is. So I have natural log. Why is this not in good focus? Of 1 plus, I said 0.1, so 0.1. And I get 0.0953. So would we say that this is a good approximation or not a good approximation? Yeah, I would say it's pretty decent too. And it's never going to be perfect. But remember, it's just an approximation. It gives us an approximate idea of which where it is approximately. It's equal again. Let's see what happens if I do. Nope, same answer appears. No matter how many times I press equal, the same answer will appear. Actually, I'm well within 5%. In fact, I'm actually within 0.5%, Joe. Because remember, percent goes to the second decimal place. So I'm actually within 1%, within 0.5%. I know, right? That is fun. That is tons of fun. So yeah. So with that, we are going to go ahead and call it a night. But before I go, I want to show you something. So, you know how normally I have like 3 or 4 note cards that I use for my outro, but I've been working on something that I think you'll like. So, this is why I wanted to wait to show you this until the end. And I think you'll like it. So, here is my new outro card. So, I'm going to be downloading all my lives and posting them here. And here is my channel over there. And once you see, if you go here and go to this channel, this is the set of all actions that you should do when you get there. You should do this, 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 and this. And then, if you want to follow me here on TikTok, you can find, here is my channel. And as you can see, I go from talk to tick, but really, I wanted to do TikTok. And then, here are a couple other people that I recommend that you follow. So if you're interested in learning about the ASVAB or the Accuplacer or a GED or the TEAS test or just need a general review in algebra and geometry, I highly recommend you follow ACG Math Tutoring. Audrey is really awesome. She does a really good job with those topics. And yeah, if it weren't for Audrey, I wouldn't even be here on TikTok. So go ahead and give her a follow. Also, I highly recommend you follow Learning with Lynette. In fact, when as soon as this is done, I'm going to be jumping into her live because I think she's still live. She went live about an hour ago. So, and yeah, she does a really good job of explaining the abacus. So I recommend and if you do jump into her live as soon as this one's done, go ahead and tell her I said hi. Or tell her I sent you. Abacus like that manual calculator. Yep. Yes, it is. And then I also offer online tutoring. So I offer both group and online and one-on-one tutoring. So for group tutoring, I offer group tutoring to groups of 3 to 10 students that are all taking the same class at the same time. So it doesn't have to be at the same school or even with the same teacher, but it must be the same class. So let's say you and 3 of your friends are all taking geometry, and you're all taking it right now, then you can sign up for group tutoring. And for that, for this school year, I charge $35 per hour per person. And then I also offer one-on-one tutoring and I price that based on how many sessions you need and how often you'd like to meet. And so if you're interested in either one of these, feel free to DM me and we can schedule a free consultation. And also, here is every subject that I tutor. I did clean it up a little bit because I think this looks a little better than this. So I cover all 4 AP math classes, as well as Algebra 1 and 2, Geometry, regular pre-calc, regular stats, all 3 calculuses, differential equations, and linear algebra. Do I teach set theory and proofs? It has been a minute since I've done either one of those. I teach set theory as a part of stats, but I don't really go into deep set theory. Thank you, Carolina, for the follow. And so, also, I am currently working on some things for you all. I'm working on some calculus flashcards that are going to be really awesome. Right now, my first set is going to be on derivatives. There we go. Now, let's say it right, Robert. And then, I'm also working on my tips and tricks to calculus. Because I don't want it to be just, I don't want it to be just like, here's a list of formulas. No, I want to show you what allowed me to be successful in calculus. And I also want you to know what didn't make me successful in calculus. And then I am also working on my calculus notebook. I'm still in the very early stages of that. Hey, Lynette, I actually just told people to follow you. So she actually is the last comment so far. So everyone, go ahead and give Learning with Lynette a follow. She's really awesome. Did you just finish your live? You're welcome, Lisa. I'm always happy to help. Yeah, so also, I go live every night at 11:30 p.m. Eastern Time, but I did say that I'm working on a second live. I will have a time for you. Ideally, I'm working out a couple plans, but I'm gonna be announcing that probably by the end of this week. So keep on the lookout for that. Thank you, Learning with Lynette, for the heart me. Thank you so much, Lynette. Yeah, you just finished? Okay. I was actually just telling people that as soon as I was done here, I was going to jump into your live. But, yeah. So, yeah. So like I said, I'm going to be downloading this live as soon as we're done. And then you'll be able to find it here. Give me about 2 hours, and it should be up. It might not even be 2 hours, but if you turn on your notifications, you'll know exactly when it pops up. Yeah. So with that, I'm going to go ahead and call it a night. Have a great rest of your evening, everyone. Thank you for joining me tonight to discuss linear approximation. And I will see you all tomorrow at 11:30 p.m. Eastern Time. Or for me today, because it is now almost 20 to 2 in the morning over here on the East Coast. So, thank you, Lisa, for the 8 more roses. Thank you so much for that. But yeah, so have a great night, and I will see you all tomorrow. Bye, everyone.